Okay, in this video I wanted to take a few minutes and discuss equivalent fractions and really understand that concept and to look at that visually so that you can really get the concept of how different fractions are equivalent to one another. And remember from our previous videos and what we've been working on, if you can get a fraction, then you can convert that then into a decimal or a percent and work with it and do whatever mathematical operation you need to do. And so with that said, let's take a look at some equivalent fractions. So I'm going to pause the video here and just bring in a couple of fraction bars to work with. Okay, so I brought these in, and let's think back to our basics of fractions video where we discussed what the numerator and the denominator actually meant and start there. Okay, so what if let's look at it this way. Let's start with this first box here. Again, this could be a birthday cake or whatever we're working with, and we needed to determine, in a fraction, to be able to work with this with fractions. We can already see it's already split up for us. So the denominator, if you recall, is what? It's always the number of pieces this whole thing is split into, right? So the denominator for this, anything we were working with this box would be what? 1, 2, 3. It would be a 3, right? And the denominator always goes on the bottom. So that's always going to be 3. And since there are three fractions we can write here. So I'm going to put 3 out here. And then we're just going 3 times, and then we're going to shade. Okay? So what is the first one? What if we had this? Okay, shaded. So that's what we're talking about, the shaded portion. So that would be 1/3, right? Because the numerator, the top number, is the number of the pieces that we're talking about, right? So 1. Alright, so what would then come next? Let's say we had this. Okay, that's shaded. How many are shaded now? 1, 2. So now we have 2/3. And the last would be if we had the third piece shaded, which means it's all shaded, which is written as 3/3, which is the same as 1, right? Any number divided by itself is always 1. So that, and since the whole thing is shaded, that equals 1. 3 out of 3 pieces shaded. Okay, so just some basics to talk about there. So I'm going to take the shading off and we'll move from there. Alright, let's get this erased. Okay, now the purpose of this was to discuss equivalent fractions. Now if you look at this, I think you can tell from the video that each of these boxes, the whole box, is the same size as any other one, right? I think you can see that they're lined up so that you can see it. So we're just going to discuss equivalent fractions from this point. Alright, so looking at this, let's kind of go back and do what we did before. Let's get the denominator for each one of these, the bottom number for each one of these boxes. All the same size. This is split into how many pieces? 1, 2, 3. Denominator is the number of pieces it's split into, right? Right. So the denominator here would be what? 1, 2, 3, 4, 5, 6. 6 pieces. Okay? Denominator here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pieces. So graphically, just look at this and tell me what you're kind of noticing. I hope that you're noticing that the way this is split, that there's kind of something in common here, and the number of columns, just to discuss some vocabulary, columns are always vertical. Okay, up and down. The way you can remember that is like in architecture or in a building or on a porch or a carport, where what's holding it up are the columns. The columns hold it up. So just remember that. That's the vertical part. Okay, but you can see each one of these has 3 columns, right? I'll just draw here. 1, 2, 3. Okay, 3 columns, right? Alright, so that's something that we have in common. So let's say I had this shaded right here, and I asked you to give me to shade these equivalently. So now that we've shaded that, we can tell that we're talking about one part of this, of the 3, so 1/3. So that is equivalent to what in these other 2 boxes? Well, this has 6 total pieces. So just looking at it visually, you can probably see to make these to have the same amount of area shaded, we would need to let me do that again. Let me do it in the same color, orange. Okay, we would need to shade that, right? Can you see that that's equivalent? And then in the third one, we would need to shade all of this. Okay, so let's just write that the equivalent fractions there real quick. Alright, so here we have 6 total pieces, 1, 2, 3, 4, 5, 6. We discussed that. What goes in the numerator, the top number, what goes in there? The number that we're talking about. Since we're talking about the shaded parts, we've got 2 parts shaded. 1, 2. 2, let me do that in blue, hold on. Okay, 2 out of the 6 are shaded. Okay, now down here we said the denominator is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 total pieces. How many are shaded? 1, 2, 3. 3 are shaded. Alright, so can you see that this is all equivalent? I think you can. And let's prove it to ourselves. What's one way we can prove to ourselves that 2/6 is equivalent to 1/3? Let me back up. Which one of these is reduced? Which one of these cannot be reduced any further? Okay, I hope you said this one, right? We can't reduce that one anymore. But we can reduce these. So let's do that. So how can we prove 2/6 is equivalent to 1/3 mathematically? Well, we can reduce it. If you take any fraction and reduce it all the way down, and once you do that and it equals another fraction, then that's how you know that they're equivalent. That is the key. You have to reduce the fraction. If you do that, you can tell if they're equivalent to one another. And from our other videos, when you have a fraction, we know how to convert it to a decimal or a percent now, so you can do any comparison under the sun at this point. Okay, so 2/6. Alright, so what jumps out at us here that we can reduce this with? Well, 2 is a common factor here, right? So 2 goes into 2 1 time, 2 goes into 6 3 times. So there we go. We've reduced that all the way. We can't reduce it any further. It matches. That's not a very good arrow, sorry. But it matches, so that is equivalent. And we can see visually what that means. It is visually equivalent here. Okay? Now let's reduce 3/9. What jumps out at us here? Common factor would be 3. 3 goes into 3 how many times? Once. Goes into 9 how many times? 3. 1/3. Checks with 1/3. And we are equivalent. Alright, so you can see that the way the equivalent fractions work, you know that you need to reduce them, and here's why. Here's visually, when you look at this, why 1/3 is the same as 3/9, the same quantity. If you were eating, let's say this was a large birthday cake, and you could then say that eating 3 pieces when the cake is split into 9 total is the same as eating one big piece if the cake is only split into 3 large pieces. You can see that 3/9 is equivalent to 1/3. So however you cut the cake, whether you cut it into thirds, sixths, or ninths, you can get an equivalent part. 1/3, 2/6, 3/9. Alright? And again, once you've got the fraction, we know how to go to a decimal or a percentage. So, you know what? Why don't we do that? Okay. So let's say we had 3/9. Let's work with this one. And I said, okay, this is shaded. You've already got the fraction. Now give me the decimal of the part that's shaded and the percentage. Okay. So remember, if we've got 1/3 here, and we need to go and get, let's do the decimal first. How do we do that? Well, mathematically we said this is 1 divided by 3, right? If we just wrote that out, let me write it out. 1 divided by 3, right? So let's do that. 1 divided by 3 gives us our decimal. 3 will go into 1 0 times, put in our decimal there. 3 will go into 10 times, 3 will go into 10 3 times. 3 times 3 is 9. We have 1 left. Bring down another 0. Okay, 3 goes into 10 times 3 times. And we'll just stop there because you're going to see a pattern, of course. We'll have 1. If we brought down another 0, we would just keep getting 3, 3, 3, 3, 3, 3, 3. Okay, so this is far enough. 0.33 is our decimal, which is the same thing as 33/100ths, right? And to go from a decimal to percent, what do? We move the decimal 2 places to the right and add a percent sign. Okay, 1, 2, that gives us 33, slap on a percent sign and we're done. So of this box right here, let's say it's a birthday cake again, the shaded part is 1/3 as a fraction, 0.33, and that will repeat, and that's something we'll discuss later on. But 0.33 as a decimal, or 33/100ths, and then as a percentage, 33%. So 1/3, 0.33 repeating, and 33% are all the equivalent forms from fraction, decimal, percent. Okay? Alright, see you in the next video.